Algebras, and here is our Chapter 1, Lesson 6 Notes, Day 1 video. So for Lesson 6, there are going to be 3 total days. All of those days are talking about linear inequalities. So that's why they're all part of Lesson 6. But each day is focusing on different pieces of solving linear inequalities or graphing the solution sets to linear inequalities. So let me first do a real quick reminder, and I usually write this right at the top of my paper, so I'll do that now. Inequality symbols are less than, greater than, less than or equal to, greater than or equal to. And inequality symbols are comparing the sizes of your two numbers. Okay, that's what they're doing. So we're looking at if your variable is on one side, the left side, then the number on the other side is saying, oh, okay, so let's say right here, we want our variable alone. We would just move the 4 to the other side, right? Well, even with an equality sign, you can follow those properties of real numbers and you get x is greater than 5. That means x can be any value that is bigger than 5. Now, an inequality is also, while it's giving you a infinite solution set, so it's not giving you one specific answer. It's not saying x is 5. It's saying that x is something that's bigger than 5. So the answer for x could be 10. It could be 58. It could be 375. But it's something that's bigger than 5. It can't be 4. It's not bigger than 5. It can't be 5 because 5 is not bigger than 5. So what I've done by having a solution set as my answer is I've given you an infinite number of numbers that could make my variable true. So what I do to represent that visually is I take my number in question, which in this case is a 5, and I put it in the middle of my number line. Now notice I've evenly spaced dashes in both directions. I'm going to put on my number line some numbers that are bigger than 5 here and some numbers that are smaller than 5 here. So the number line always goes in the same direction. Smaller numbers are on the left and the bigger numbers are on the right. My number in question is in the middle. Okay, just like a regular number line is. All right. Notice I have a scale going. So I decided that my scale was going to go by ones. So each dash is worth 1 going up my number line. Now, x can be greater than 5, right? So that means my answer can be 6, 7, 8. It could be 7.5 because that's a number greater than 5. It could be 6.3 repeating because that's a number bigger than 5. So I need to represent visually all of the numbers bigger than 5. I can't include 5. So what I do is I put an open circle over 5 because 5 is not included in values that are bigger than 5. So opening that circle over it says I'm starting here, but it's everything bigger than here. And then I cover all the numbers bigger than this with an arrow to the right, heading that direction. That's representing, that is my solution set representing all numbers bigger than 5. Okay, this was my answer. X had to be greater than 5. This is how I represent that answer as a solution set. That's how I graph the solution set. Now, I just want you to take note of what I did at the very beginning. And again, I kind of assumed that you knew how to do this already, having been in 8th grade and done this, right? We still treat inequality signs with the same idea as the balancing act of an equal sign. Okay, we treat them the exact same way because the properties of real numbers are still applying to my variable because my variable is still a real number. So I'm still using the additive inverse in conjunction with the addition property of equality. Now I'm going to do that on the other side too. Okay, over here. I want all my variables on one side of the inequality sign. I want my numbers on the opposite side of the inequality sign. So when I have an inequality sign, want my variables on the left because it's easier to read. And you'll watch me do that as we go today. Okay, that'll be one of the things I focus on. So since that's the case, I'm going to move my variables from here to the left. So the opposite of a negative 2x is a positive 2x. I add 2x to both sides of the equal sign. Notice I'm lining up my like terms over here. 5x plus 2x is 7x. Okay. I'm going to bring down my plus 4. I'm going to bring down my inequality sign, less than or equal to. I'm going to bring down my 11. Since my variable's on the left, my number's on the right. So the opposite of a positive 4 is a negative 4. I subtract 4 from both sides of the equal sign. I'm left with 7x is less than or equal to 11 minus 4 is 7. Now, same thing goes here. The opposite of multiplying by 7 is dividing by 7. So I'm going to divide both sides by 7. And I get 1x, or x, is less than or equal to 7 divided by 7 is 1. So my solution set is that all real numbers, 1 and lower, will make this inequality work. Okay? So any real number that is 1 or lower will make this statement true. So again, what I'm doing is I put 1 in the center of my number line. I put dashes on each side. I kept my scale the same. So I've got a couple numbers smaller than 1, a couple numbers bigger than 1, but I've got my number in question in the middle of my number line. This time, because I've got the equal to part, I get to do another part, which is fill in my circle. Okay, so I filled in my circle. And now all my x values have to be smaller than 1. So that means cover 0 and -1 and -2 and -3 and all the way to negative infinity this direction. That's how I'm visually representing the infinite number of numbers that make this inequality work. Okay, my answer is x is less than or equal to 1. All right, now, something you need to keep in mind when solving linear inequalities is that there's this little thing that happens when you have a negative, when you multiply or you divide by a negative number, where the inequality sign needs to flip around. So that's this fill in right here. When you multiply or divide by a negative number, you must flip the direction of the inequality sign. You must. Okay, that's just something that happens. Let me just do this right over here in a little bit of blank space over here. It's just something that happens because let's say you've got 3 and 5 and you're comparing them. Okay, we know right now that 3 is less than 5. Okay, I'm going to use the multiplication property of equality. And what I'm going to do is I'm going to multiply both sides of this by -1. So this is me multiplying both sides by -1. On this side, I get -3. On this side, I get -5, right? But -3 is a greater value than -5. So what did I do when I multiplied or divided by a negative? I changed the worth. I changed where the greater amount was. And how I deal with that is flipping my inequality sign over. So if I'm solving a linear inequality and I happen to multiply or divide both sides by a negative number, the inequality sign must flip over, whatever it is, okay? So let's look at a problem that will deal with that, right? First thing I notice is I've got to distribute this 2. So let me start there. 2 times 2x is 4x. And 2 times -8 is -16. Bring down my -8x, bring down my less than or equal to, bring down my 0. All right, I've got 2 like terms on the same side of an inequality sign or an equal sign, so I combine them. 4x minus 8x is -4x. Minus 16 is less than or equal to 0. Well, let's get all our numbers on the right-hand side. Like I said, I like my variables to stay on the left when I'm dealing with inequalities. My numbers on the right. So let's add 16 to both sides of the equal sign. And they cancel out here, leaving me with negative 4x. Bring down my less than or equal to. 0 plus 16 is 16. Additive identity. The opposite of multiplying by negative 4 is dividing by negative 4. I am about to divide both sides of an inequality sign by a negative number. So while that does cancel to be a positive 1x, which is my goal, of course, in the process, I need to flip this to becoming a greater than or equal to sign. On the other side, 16 divided by negative 4 is negative 4. So now that means that when I create my solution set on my graph, on my number line, I put the number in question in the middle, negative 4, a couple numbers greater on the right-hand side, and a couple numbers smaller on the left-hand side, and I stick to my scale. I don't get to change my scale midway. I have to keep my scale going, right? It's greater than or equal to, so that's a closed dot. Got that extra piece on your inequality sign, then you get to fill in your dot. X is greater than or equal to negative 4. Okay, so all the things that are bigger than negative 4 are this direction. And what's pretty cool is if you keep your variables on the left, and this is part of why I like this, you can follow the arrow of your inequality sign when creating your number line. Real quick, I'm just going to do something to show you that this is true, okay? And I'm going to take negative 1, and I'm going to check it in my original inequality. So everywhere I see an X in my original inequality, I'm going to put a negative 1 in for it, okay? So let's just do that real quick. I'll mark this CK for check, and I'm going to do 2 times negative 1 minus 8 minus 8 times negative 1 should be less than or equal to 0. And let's just double check how that works out. So I'm going to do inside the parentheses first. 2 times negative 1 is negative 2. Negative 2 minus 8 is negative 10 inside the inequality. Out here, negative 8 times negative 1 is a positive 8. Bring down my less than or equal to and my 0. 2 times negative 10 is negative 20 plus 8 should be less than or equal to 0. Negative 20 plus 8 is negative 12. Is negative 12 less than or equal to 0? Yes, it is. So this value, which was a value greater than negative 4, made my inequality statement a true statement at the end. When you're looking at checking an inequality, that final statement needs to be true, okay? So when you're checking an inequality, the final statement must be true, whatever it is. Notice I don't need the same number on both sides of the inequality sign because it's not necessarily equal. All right? Great place to stop, take an assessment, move forward, right? I spread out examples a lot here. Okay, there's a lot more examples here. There's 10 examples. I'm just going to do a couple of major ones so you can see a few pieces here, things that I'm focused on, things that I'm looking for, and how to do your answers, right? So let's start with number 1. The number line that's under each of the questions, each of the problems, is the number line to put your solution set for that problem on. Okay, negative x minus 2 is greater than 4. Okay, add 2 to both sides. Cool. Negative x is greater than 4 plus 2 is 6. Is my x alone? No. It's multiplied by a negative 1. What's the opposite of multiplying by negative 1? Dividing by negative 1. Divide both sides by negative 1. And I divided by a negative, so I flip my inequality sign over. X has to be less than negative 6. So on my number line, negative 6 in the middle, and a couple numbers greater than negative 6, a couple numbers less than negative 6. Negative 6 is my number in question. So let's see, put an open circle over the negative 6. X has to be less than. If my variable is on the left, it's more easily readable. and I can follow the arrow of that inequality sign to know which way it goes on the number line. So there we have it. Let's do another one like number 2. And the reason I picked number 2 is because while I'm trying to get my variable alone, the first thing I'll end up doing is moving this number, 17, over to the left-hand side and getting all the numbers on the left-hand side of the inequality sign. But like I said, I like to read, now my variable's alone, but I like to read my variable from left to right. So since my variable is alone, I'm technically done with this problem. All I'm going to do is flip everything around so that I read the y first. Notice the mouth of the inequality sign was facing the y, and the number had kind of the arrow end to it. So instead of reading it as 2 is less than y, I'm going to read it as something that makes a little more sense in my brain. Y is greater than 2. So 2 goes in the middle. Greater stuff on the right here. Less stuff on the left. And I'm going to put my number in question. So circle over the 2 in the middle. Y has to be greater than 2. So I cover all the things that are greater than 2. I want you to think about it. These are the exact same answer. Okay, those are the exact same answer. They say the exact same thing. 2 is less than y. Look at that. 2 is. It's smaller than all these y values that I just listed on the arrow. But your brain likes to think in terms of the variable compared to the value. And that just makes things a little bit easier to understand. Y greater than 2. Yep, all my y's are greater than 2. Okay, put that variable on the left. Makes it so much easier to read and understand. Let's do a little more complicated. Let's go down to number 5. Variables on both sides. See, I'm going to put my variables on the left. When I've got the option to pick which sides, put those variables on the left right off the bat. So let's add 3y to both sides. And of course, I'm combining like terms. This is the first time I'm going to do this in front of you, but I'm going to do the same step for moving the negative 18 by adding it to both sides. So now I'm going to move the 18 by adding it, okay? So now I've got all the variables over here. Okay, negative 3y is less than 24 plus 18, okay? 24 plus 18, 42. Now, the opposite of multiplying by negative 3 is divide both sides by negative 3. So let's do that. I am dividing by a negative to get my 1y alone. So my inequality sign has to flip over. And now 42 divided by negative 3, gosh, I'm pretty sure it's 14, but whew, yeah, there we go. 14. I just had a slight brain fart, so I wanted to double check myself. Negative 14 goes in the middle. My larger numbers on the right, my less numbers on the left. Negative 14, open circle over that negative 14. Y is greater than negative 14, so cover all the things that are bigger than negative 14. Why didn't I, apologies, that was down a little low. Why didn't I put an open circle on my number line? Because I didn't have an equal to part. So I didn't do the extra step of filling in because I didn't have the extra piece under here. I kind of think of it as that extra, right? Those kind of go together. Let me just do number 4. Can you have decimals involved? Of course you can. They're numbers. They're real numbers. We've talked about real numbers. We know how to use real numbers. They hold the same properties as integers, so we can do this. I'm trying to get h alone. So currently it's multiplied by 2.4. We divide both sides by 2.4. Okay, just to kind of give you guys an idea. Pull my graphing calculator up. Eventually it'll be on my calculator or on my computer screen, but they still haven't put my emulator up. Okay, so negative 24 divided by 2.4, I get negative 10. And these had, of course, had canceled out and gave me my 1H. But I just got done with this. I don't like reading it this way. It's harder to put on the number line. So I am going to flip everything around so that my variable is on the left and my number is on the right. But notice the mouth of the inequality sign still has to face the same place. Okay? Still has to face the same direction, just like that. So this is the one I read because I like to read the variable left to right. Read the variable first left to right. So negative 10 in the middle. There we go. Some numbers less than, some numbers greater than. And this time I do get to fill in my circle. H is greater than or equal to negative 10. Okay, so the values that are greater than or equal to negative 10, negative 10 gets filled in as one of the potential answers. And then I cover all of the things that are bigger than negative 10. So moving right from there. Alrighty, let me just check to make sure I don't have anything else crazy going on. Oh, let's do number 7, and I'll stop there. Because sometimes people freak out with a fraction. Again, I want to remind you that a fraction is just a division problem. So here's how I'm going to handle this so that you don't freak out. Right now, because this is a division problem, what value in it am I dividing by? Dividing by 3, okay? So the opposite of dividing by 3 is multiplying by 3. Let's take this in 2 steps since there's 2 numbers here. Let's multiply both sides of the inequality sign by 3. That way these 3's cancel out. I'm left with negative 2z. Bring down your inequality sign, and 6 times 3 is 18. Okay, so now this makes a lot more sense, right? I've got this negative 2 multiplied by my z, just divide both sides by negative 2. These cancel out. I'm left with z. I flip this around, so it's less than or equal to, and over here, 18 divided by negative 2 is negative 9. Okay, kept my variable on the left. I just took that fractional problem as a division problem, dividing by the denominator, the opposite of dividing by 3, multiply both sides by 3. And once I did that, it was like using the LCD. It was clearing my denominators out, okay? So now let's put that negative 9 in the middle, a couple numbers greater, a couple numbers smaller, and dot. Z is less than or equal to negative 9. Okay, stuff smaller than negative 9 is off to the left. So negative 9 gets a filled in dot, right? So fully filled in dot, extra piece, extra writing, and then arrow to the left. So I was following the same arrow as that inequality sign. Alrighty, guys. Think you should be okay. Again, still following the real numbers. I've got more examples if you need them. Sign up for office hours if you need them. But I want you to be working on the homework that goes with this, solving, and then putting your solution sets on here on your given number lines. Okay? I shall be seeing you soon. There we go. Have a great day.